Hello all. Aakriti Education brings you the analysis on previous year IIT-JEE questions. In this video, we will discuss question number 8 of section 2 asked in Advanced Paper 1 2020. Question says, let M be a 3 by 3 invertible matrix with real entries and let I denote the 3 by 3 identity matrix. If M inverse is equal to adjoint of M, then we need to find which of the following statements are always true. Now first, if we analyze the question, it is given that M is a 3 by 3 and invertible matrix. It means M inverse will exist. It is also given that M has all the real entries. It means M inverse will also have all the real entries and determinant of M will also be a real quantity. Now we proceed with the given equation as M inverse is equal to adjoint of M. As we know that adjoint of A can be simplified as determinant of A times inverse of A. So the equation can be simplified as M inverse is equal to adjoint of determinant of A times inverse of M. We also know that adjoint of K times A, where K is any constant, can be simplified as K raised to the power n minus 1 times adjoint of A, where n is the order of square matrix A. Then M inverse can be written as determinant of M square times adjoint of M inverse. Further, by using the fact that adjoint of A is equal to determinant of A times inverse of A, M inverse can be simplified as determinant of M square times determinant of M inverse times M inverse of inverse. As we know that determinant of A inverse is same as inverse of determinant of A and inverse of matrix A is same as matrix A. So M inverse can be simplified as determinant of M into M. Now after pre-multiplying both the sides of the equation 1 by matrix M, we will get M times M inverse is equal to determinant of M times M square. Since M times M inverse is equal to an identity matrix, so it will give I is equal to determinant M times M square. By taking the determinant both the sides and by using the fact that determinant AB can be splitted as determinant A times determinant B, it will give determinant I is equal to determinant of determinant M times determinant M. Also, we know that determinant of I is equal to 1 and determinant of K times A is nothing but K raised to the power n times determinant of A, where n is the order of square matrix A. Then we will get 1 is equal to determinant M raised to the power 5. Now it is given that M has all the real entries. It means M is a real matrix and hence determinant M will also be a real quantity. Thus it will give 1 is equal to determinant of M. If M would be a complex matrix, then it would have complex solution. Now if we substitute determinant M is equal to 1 in equation 2, we will get M square is equal to identity matrix. Further, we have to solve for adjoint of M whole square, which can be written as adjoint of M square, as adjoint of AB can be splitted into adjoint of A times adjoint of B. So adjoint of M whole square is nothing but adjoint of M square. Since M square is an identity matrix, so it will give adjoint of identity matrix, which is an identity matrix. Thus adjoint of M whole square is an identity matrix. Now here one more thing has to be observed, that M is equal to I is satisfying the given equation as M inverse is equal to adjoint of M. It means M is equal to I implies M inverse is equal to adjoint of M. But it is not always true, because M inverse is equal to adjoint of M does not imply M is equal to I. Thus, it is not a correct option. Hence, the only correct options are 2, 3 and 4. Thank you all. If you find this video interesting, please like, share and subscribe our channel for more updates.